Hi, it's Nono here, and we're just briefly going to see what Google Colab is. If you're familiar with Python, Anaconda, and Jupyter notebooks, this is really similar to Jupyter Lab, but on the cloud. How can we open a Jupyter notebook? In Google Colab. So we just go, this is a normal Jupyter Lab notebook that is running on my machine. So you can see that I have here TensorFlow, and I have the library loaded, and I can do things like, I don't know, just create a tensor from an array of 3 numbers, right? How can we do this on the cloud without having to start running this on our machine? We'll go to colab.research.google.com, and then we'll get this page that loads or lets us create new notebooks. If we create a new notebook right away on the cloud, we have a Jupyter notebook that is running on our browser and has nothing to do with our computer's backend. So I'm just gonna add here a date to mark that this is something that we're working on right now. Live session 2, Google Colab 101. Right, this is Google Colab. As you can see, it's a version that Google did, sort of a fork from a Jupyter Lab. So what we had before running there that you can see in here is Jupyter Lab, and is really similar, so it has the same functioning, but Google has redesigned and remade it a bit. In each of these cells, you can add text or code. So when they say text, you can add formatted text or markdown. So I can do here, for instance, Google Colab 101, right? And I press Shift Enter to execute the cell, and then this gets rendered as markdown. We're just going to move that up, and if I double click, I can edit. I can say this is a starter tutorial as part of the machine learning series by Nonoma. That's how it shows up, and we can even add see links and resources, and I can add a link here if I want it. So this is fully parsed markdown to HTML in a Jupyter notebook cell as normal Jupyter notebook. Now here I can also add code cells. So every time I click, I add a code cell that I can run Python in. So I can say, for instance, a equals 1 and b equals 10, and I can return on this cell a plus b. So we get 11. And we can do more interesting things like importing TensorFlow. I can do here things like this. So I can import TensorFlow as TF and then print the TensorFlow version. And when we do this, allocates a kernel on the backend for us and displays the version of TensorFlow that is running on this Python environment. We can do a bit more stuff here, so we can print the Python version as well and see what we have on the backend. So right now we're seeing here we have TensorFlow 2.3, Python 3.6.9, we have a CPU, and we get some information about the CPU device that we have. What's nice about this is that on runtime, change runtime settings type, we don't have any hardware accelerator. We could accelerate our code with GPU or TPU. So for now, we'll just get a GPU, which we're not going to use, but we'll just see. So now when I look at here, that was really fast. So if I change my runtime and press save, that we're getting allocated, new kernel gets initialized. We can see the engine that we're running it on, the memory and the RAM memory we have. And I want you to look at here right now. So as I click here on GPU and save, so this is connecting, initializing Python, connected. Really quickly, it finds a machine for you to run this that has a compute engine backend GPU that is provided by Google. So before we had a CPU, but now by running the same cell, we're gonna see that we have Python 3.6.9, so it's higher version, still TensorFlow 2.3.0, but now we do have, apart from the CPU device, we have this GPU XLA device, XLA GPU. And we could use that to train our machine learning models on the cloud, or to do operations with TensorFlow, for instance, that require GPU. All right. 101, this is exactly a Python notebook, and this Python notebook you can save a copy in Drive, or you can download as a Python file. You can do other things there. If you download this as a Python file, you can just open the code that is on it in your machine. We just have this, and you will be able to run this code anywhere. And also this markdown is here. If I download the Python, so the Jupyter notebook, I can also open that with Visual Studio. So we can go here, for instance, and go to the downloads folder. So let's see what's in here. So code, whatever is with the notebook extension. Visual Studio Code opens, and because I have installed the necessary extensions, I can select a Python interpreter. I can select this one, and after this loads, I'm going to be able to run. We can see that the output of the notebook is shown, the markdown is rendered, and I can run this cell and execute it. So this will load TensorFlow again, print the version of Python, and display the devices that are available on this backend. Something really easy that we can do today is an array in Python. So let's say we encode the information for an image. Could be as simple as a one-line matrix. So we could say the red color, so these are RGB values, so the green color and the blue color, right? So this is an array that has 9 numbers in what could be a line or like a matrix. This is actually a 3x3 matrix, so it has 9 values, 9 integers. What we can do with this now is that we can say convert this image, and TensorFlow is going to convert to tensor. So tensor is the data structure TensorFlow uses to keep data. Might be a one-line array, or an image that is a 2D array, or 3-dimensional arrays like voxels or multidimensional data. If we print this again, so print the image again after converting it, now we see this is a tf.tensor object with shape 3, as I said, it's a matrix that is 3x3, so it's a shape 3, so it contains 3x3 is 9, so it contains 9 values, and we have 255, 00, that's RGB values. How can we display this? So let's see if we import here matplotlib, and we just plot to show that image. We'll just do deactivate the access, and we'll just try to show that image. Let's see what happens. We'll probably, you get that there, but that is actually just displaying the matrix of objects there as an image. So it's actually showing a matrix where this is 255, 0, 0, 0, 255, 0, 0, 0, 255. What we can do here is when we show the image, we can change the CMAP to be gray, and let's see if that works. Yeah, so now we actually get the 255 is white and the 0 is black, and we can change this. Let's get more room here. So we could change without printing this. So let's actually merge these two cells. So or merge the entire thing. Let's just copy this over to here. Also image bar. So I can put this color, instead of being completely black, I can say this is going to be a 50. So 50 means like it's a bit like lighter. So we get gray. And what happens here, so I'm going to have to put a 0 here to get the grays, because what this function does is that it stretches the values to go from 0 to 1. So it will get the minimum and make that 0, and the maximum and make that 1. And that way it contrasts the image a lot. So what we're going to do, maybe add this to be 200. Now we start getting those colors to be black and white color. But what we can do as well is here, we could say tf reshape, and we can say this is a 3x1 image with 3 channels, right? So we'll say image, and then the shape is this. And in summary, if we build an image like I had at the beginning, so we have a red, RG, so green and blue, and I run this again, we get the red, green and blue. So this is, if we change dimensions, so now we're going to get actually the width to be 3 instead of the height. We could put more rows next to this. So we could say, okay, now I have this, but I'm going to have here this to be an array, so we can actually make this a bit more understandable if we do this. Yep, so the shape doesn't match. So now we want to reshape it to a 3 by 3. So we have a line that if we change, for instance, this color here, so this value here are the RGB values for this block in there, that cell. And we could leave this like that and maybe say, okay, this is 127 and this is 50, and we're just gonna do that with all the colors to fade them to a darker shade of their color. What we have here is a tensor that is getting represented as an RGB image. We have 3 by 3, which is 1, 2, 3, 4, 5, 6, 7, 8, 9 pixels, or pixels or units, and then 3 channels. So the color of this cell is defined by 3 elements, which are like 0, 0, and 2 to 5. All right, so that was an overview on Google Colab. Hey, it's Nono. This video was part of the machine learning series. Please go ahead and like it if you'd like to see similar content on my channel. And subscribe if you want to get notified when I publish new videos or when I go live. Thanks so much for watching. I'll see you next time.